Question where I made a mistake in the last video. Towards the end, I told you to ignore there because the position of the fourth bright fringe from the center. You don't have to put y4 minus y1 and all because the distance itself is from the center, which is y4 is equal to 4 into lambda into capital D by small d itself is 1 centimeter. So 4 into lambda you don't know, capital D is 0.03 in 10 to the power minus 2 by small d is capital D is 1.4 by small d is 0.03 in 10 to the power minus 2 is equal to 1 into 10 to the power minus 2. Cross multiply, get the value of lambda, you're done. Such an easy sum. You will get 5000 Armstrong to be the answer. Okay, I made a mistake in the last video, I'm sorry, but I hope you all understood that you're not supposed to do something like that. So 11th question, the two slits are a small d is equal to 0.125 into 10 to the power minus 3 meters, is illuminated by the wavelength of 4500 Armstrong. The screen is capital D is equal to 1 meter away. Find the separation between the second bright fringe on both sides of the central maxima. Second bright fringe on both sides, the distance between them. You just find the position of the second bright fringe from center and double it. The position of the second bright fringe is 2 into lambda into capital D by small d, and double it, you will get 4 into lambda into capital D by small d. Just do the calculations and you will get the distance. That completes that sum. Is very simple. I don't know, this paper is very obviously very easy. The double slit is illuminated by a light of 6000 Armstrong. The slits are 0.1 centimeter apart. And the screen is 1 meter away. Calculate the angular position of the 10-degree maxima. Angular position, okay. Angular means it's theta is equal to x by capital D. That's what I know. You can also write this as sin theta is equal to x by d. Or a tan theta is equal to x by d, you never know. But this formula we got x by capital D, sin theta is equal to x by capital D, where x is the position on this distance and d is this distance, okay. So which means it's tan theta? Yeah, could be, no? Tan theta is equal to x by d, never know, I don't know. But previous sums we have taken it only as sin theta. So let me continue to take it as sin theta only, okay. Because I substituted sin 30, remember? Yeah. So let me take it as sin theta. So 12th question, 10 degree, the angular position of the 10-degree maxima. I'm so sorry, I can't see it. Angular position of the 10th maxima, sorry. Angular position of the 10th maxima. The angular position is theta is equal to x by d. 10th maxima's position is 10 into lambda into capital D by small d. This is what is the 10th maxima's position. Okay, and that can be substituted in the place of x. And the separation of the two adjacent minimas, that is nothing but bandwidth. They are asking for bandwidth. So calculate the angle, calculate the angular position of the 10th. Okay, let's find the position of the 10th maxima. And when you substitute this here, theta will be 10 into lambda into capital D by small d into capital D, you get cancelled. You don't need capital D. 10 into wavelength itself 6000 into 10 to the power minus 10 by small d itself 0.1 into 10 to the power minus 2. Let me see if this is going to work. This has become 10 to the power minus 3. When taken up, it will become 10 to the power 3. It will become 10 to the power minus 7. With this 10, it will become 10 to the power minus 6. And with this 3, it will become 10 to the power minus 3. 6 into 10 to the power minus 3 is all I get. 6 into 10 to the power minus 3 is all I get, which is like 0.006 radians. Okay, so perfect. Okay, so next is to find the same type of question we have done it in the previous one. Beta is equal to separation between two minimas or maximas is nothing but bandwidth lambda into capital D by small d. You know lambda, capital D, small d, everything, you know, 6000 into 10 to the power minus 10 into capital D is 1 meter by small d is 0.1 into 10 to the power minus 2. This when taken up will make it 10 to the power minus 8. This 10 to the power minus 1 goes up, will become 10 to the power, this will become 10 to the power minus 7. It's already a 3 here, which will make it 10 to the power minus 4. 6 into 10 to the power minus 4, which makes 0.0006 meters. Okay, that will be your bandwidth. It's very, very easy sum. 13th question. In Young's double slit experiment, the apparatus is immersed in water. What will happen to the fringe width of the interference pattern? Okay, you're going to immerse the entire apparatus in water. You know the wavelength is going, initial wavelength beta is equal to lambda into capital D by small d. When you immerse it in water, you get a beta dash because the wavelength is going to change, but capital D by small d will remain the same. What is lambda dash? You know refractive index is equal to wavelength in vacuum by wavelength in medium. So wavelength in medium is lambda by mu. So you're substituting here, you get lambda by mu into capital D by small d, and comparing this is 1 by mu times the beta dash is 1 by mu of original. If you can memorize this, nothing like it. So 1 by mu of the original wavelength, and so 1 by 1.33. So if you can memorize, you have to memorize this if you can. Okay, so that makes it all sum very, very easy now. So let's go to 14th question. Consider the interference between two waves and two sources of intensities 2i and 3i are the two intensities. What is with intensity at points where the path difference is lambda? Okay, path difference is lambda. You know lambda is the path difference, phase difference is 2 pi. So this is the angle you need to put, and the resultant intensity is I1 plus I2 plus 2 root I1 into root I2 into cos 2 pi. Cos 2 pi is nothing but cos 0, so it's like 1. So this is 2i plus 3i, which is pi I, plus this itself is 2 into root 6 into I. So I can be taken out common, it's 5 plus 2 root 6. Just try to see what is the answer. The answer is, what have they said? Yeah, 5 plus 2 root 6 into I got it. Can you see? So that's the answer for when I'm considering lambda to be the path reference, where that's my answer for the first one. Okay, the next case is lambda by 4. Lambda is the path reference for 2 pi being the phase difference. For lambda by 4, what will be the phase difference? Lambda get cancelled, it will be 2 pi by 4, which is pi by 2. And for pi by 2, this resultant intensity will be just 2i plus 3i, because this cos component will be cos pi by 2, and so it will get 5i. So they have seem to have interchanged the answer in the solution. So as long as you understand that. So let's go to next question, which is the 15th question. The two waves of same frequency and same amplitude A are which means you won't get sustained interference because the amplitude has to be slightly different. Okay, anyway, two waves of you can have same wavelength but some slightly different amplitude. Okay, so two waves of same frequency and same, which means same wavelength also, and same amplitude are reaching a point simultaneously. What should be the phase difference so that the amplitude of the resultant wave is R itself is 1.732a. The original intensity is small a. Okay, and 1 second, hold on. So continuing with where I left, it's the 15th sum. Two waves of frequency and same amplitude a. Okay, so resultant amplitude, you know, R is equal to root of a square plus 2a square cos theta. Okay, two waves of same frequency and same amplitude are reaching the same point simultaneously. What will be the phase difference? Okay, cos theta, the cos phi, whatever, this is the phase difference, so that the amplitude of the resultant wave, this has been given as 1.732a, which is equal to, this itself is root 2a square plus 2a square cos phi. So you can take a 2a square common and 1 plus cos phi. 1 plus cos theta is 2 cos square theta by 2. So 2 cos square 5 by 2 will make it 4a square cos square 5 by 2, which will become a 2a cos 5 by 2 is equal to 1.732a. A and a get cancelled. So cos 5 by 2 itself is 1.732 by 2, which is 0.82 is 16. 13 6 2 are 12, 0.866. That is my angle that I'm getting. What are they asking? What would be the phase difference? So I get cos 5 by 2 to be 0.866, and you want to find what is cos 5. Cos 5 is 2 cos square 5 by 2 minus 1. So 2 into 0.866, 0.866 the whole square minus 1. What is 866 by 1000? 433 by 500. I'm not getting anywhere with the answer. Shit. 0.86. Okay, let me think. 732. They've given pi by 3 as the answer. So get pi by 6. Okay, let's see what is cos 60. Cos 60, like cos 120. What's cos 60? Cos 60 is root 3 by 2, which is 1.414, 1.732 by 2, which is 0.8. 1.732. 8 2 is 16. 13. 6 2 is 12. 12. Yeah, exactly. So therefore, you get 5 by 2 itself is 60 degree. So 5 will become 120 degree. That's what I'm getting. And 120 degree is nothing but 2 pi by 3. And I've got the answer. That's for the first case. Okay, I'm getting a second answer. And the second case is they juggle the answers. Okay, the resultant intensity itself is just A. The resultant amplitude itself is just A. So if you're going to have A is equal to, so the whole thing you're going to replace A is equal to root of, so this itself is simply A. If it's simply A in the second case, then in that case the A and A will get cancelled. 1 is equal to 2 cos 5 by 2. So a cos 5 by 2 is equal to 1 by 2. Cos 60 is what is 1 by 2. So 120 degree. Second case I'm getting 120 degree. The first case, is it wrong? Plus 2a 2a square cos 5, which is 2a square plus 2a square, 2a square 2 cos square 5 by 2, which is 4a square cos square 5 by 2, which is 2a into cos 5 by 2. Cos 5 by 2 is 0.866. So 5 by 2 itself is 60 degree. You're getting I'm getting the same answer 2 pi by 3 in both the cases. How is it possible? Means 1.732a, and means when it's just a, there should be some difference to it, no? So if it's just a, let me see, if it's going to be just a is equal to 2a into cos 5 by 2, where a and a get cancelled. Cos 5 by 2 is equal to 1 by 2. When will cos 5 by 2 be just 1 by 2? 5 by 2 will be 1 by 2 only in 60 degrees. So 5 is equal to 120, which is 2 pi by 3. Pi by 2 is equal to pi by 3, pi is equal to 2 pi by 3. I don't know how they are arriving at pi by 3 as answer. I'm getting only 2 pi by 3 because I'm eventually finding out only cos square 5 by 2. Just check out, guys, okay? See if you can 1.732 2a cos phi by 2, 1.732 divided by 2 0.866. That can happen only when cos, maybe it's 30 degree here, maybe root 3 by 2 cos, when it will be root 3 by 2 it will be at 30 degrees, so phi by 2 is equal to 30 degrees, so phi is equal to 60 or a pi by 3. I got it, I made a mistake there. Okay, so that's what it is. I hope you can correct it. So first answer is pi by 3, next answer is 2 pi by 3. Let's go to 16th question. Two coherent sources of light emit waves of amplitude A and 2A. They meet at a point P. Prove that the intensity of the first wave is I. What will be the resultant intensity at P? First wave. One wave is I. What will be the resultant intensity? Intensity of the first wave is I. Two coherent sources of light emits amplitude A and 2A. So we can find what will be the resultant intensity. We can find the resultant amplitude, root of A square plus 4A square plus 4A square cos phi. The resultant 16 sum. Two coherent sources emit waves of amplitude A and 2A. They meet at a point P. The intensity of the first wave is I. What will be the intensity of the first wave is I? What will be the resultant intensity at P? Okay, maybe the intensities of the individual wave is just I. What will be the resultant intensity? So they are asking resultant intensity, then if it's I can write I plus 2I cos phi, which is 2I plus 2I cos phi. Correct? But the thing is, how is it? Okay, one is I can't write it as I and I because the amplitudes are A and 2A. So let's do the sum using amplitude only. So you get 5A square plus 4A square cos phi. So what is common? A is common. 5 plus 4 cos phi. Unless you know phi, how do you do the sum? 16 two coherent sources of light A and 2A. They meet at the point intensity first wave is I. What will be the resultant intensity? Resultant intensity, resultant amplitude I'm trying to do, but I'm getting how do I do this sum? Because they're not asking for R maximum, R minimum, I maximum, I minimum. What will be the resultant intensity at that point P? Wave of amplitude A and 2A, they meet at a point. Prove that the intensity of the first wave. Prove that the intensity of the first wave is I. I don't understand this question at all. Let me surf the net. Something wrong with the question. Yeah, I got the sum in the internet. Apparently, this sum is wrong. Yeah, every time wasting time reading the question. 16th, the two coherent sources of light emits wave of amplitude A and 2A, and the question seems to be like they meet at a point P, equidistant from the two sources. If the intensity of the first wave is I don't know what else is the next question because it's not opening up for me. The question continues to be like this, so definitely this question is wrong. Please ask them to give the question properly so that we can do the sum. Let's because it's not coming for me when I surf the net. Okay, so let's go to 17th question. I have wasted so much minutes in searching this question. In the interference pattern, at a point we observe 12th order of maxima appears for a wavelength of 6000 Armstrong. 12th order maxima means 12 into lambda into capital D by small d. What order of maxima will be observed for a wavelength 4800 Armstrong? For 6000 Armstrong you order in the interference pattern at a point, a particular point you observe the 12th order maxima. So this is the distance at which you see the 12th order maxima considering 12 into 6000 into 10 to the power minus 10 into lambda d capital D in this body. Now the same position if in the interference pattern at a point we observe 12th order maxima, okay, what order of maxima will be observed for a wavelength of 4000? What order? So you for that position, you know that this becomes your position, equate it to n into Lambda is the new wavelength, which is 4800 into 10 to the power minus 10 into capital D by small d. Just equate this and find the value of n. D and D and all will get cancelled. It's very easy, okay? The punit is just make sure you're getting the value of n, okay? So let's go to 18th question. 18th question is in a single slit experiment, which means it's about diffraction. Lambda is equal to 500 nanometer, okay, is incident on a slit of width. Yeah, sometimes in diffraction they'll call it as A, but you can also call it as D, no problem. 3.5 micrometer. Calculate the angular width of the fourth maxima from the central maxima. The width of the angular width theta. For a diffraction, I just told you the formula is 2 into lambda by small d. That's for theta, where it covers central maxima, but that's not about central maxima here. This question is about angular width of the fourth maxima from the central maxima. Calculate the difference in angular width between second minimum and the fifth maximum. See, this is in diffraction, okay? This question clearly shows it's diffraction, and I know to find the angular width of the central maxima only. I know angular width of the central maxima in diffraction is theta is equal to, as I said, 2 into lambda by A or small d or whatever. This is the formula I know. I don't know to find the angular width of the fourth maxima and all. In interference I know, but I don't know to find the angular width of the fourth in diffraction. I'm sorry. So 18th question is doubt. Let's go to 19th question. A parallel light of wavelength 5000 Armstrong falls normally on the single slit. Again, diffraction. The central maxima spreads out to 30 degree. That's okay. You know that theta is equal to 2 into lambda by small a or small d, whatever. And you can call theta to be sine 30 is equal to 2 into lambda by a, with which we can find the slit width. A is equal to 2 lambda by sine 30. Just substitute and get the value, that's all. For which the width of the slit, the central maxima would spread out to 90 degree from the direction of the incident. Find the width of the slit. Yeah, we found. For what width of the slit, the central maxima would spread out to 90 degree the direction of the incident ray. So then you can write A is equal to 2 into 5000 into 10 to the power minus 10 by sine 30 is 1 by 2. So 4 2s are 2 to the 4, 5 4 is 20. So 20 into 10 to the power 3, so it will become 10 to the power minus 7. So 2 into 10 to the power minus 6. That is the width that I am getting. 19th sum. Yeah, it's 1 micro. I'm getting 2 micrometer. What is it? Look at the question. 5000 Armstrong was normally the central maximum spreads out by 30 degree on either sides of the incident light. On either sides of the central maximum spreads out to 30 degree on either sides. Then it means the angle will be 60 degree. Let's assume it as sine 60. Then I'll write it as sine 60, which will be root 3 by 2. So then therefore it will be 10 5 4 is 20 into 10 to the power minus 7 by root 3. So let's check that. 2 into 10 to the power minus 6 by root 3. It's 2 by 1.732 into 10 to the power minus 6. Even then I'm not getting 1 micrometer as the answer. It's spread out to 30 degree on either sides, which means I'm thinking it's 30 degree here and 30 degree here. I don't know. So I'm just looking at the website. Yeah, you can't take it as 60 degree. You should still consider it as 30 degree only. It may be on either sides. That's okay. So then therefore theta is equal to 2 lambda by a. So sine 30 is equal to 2 lambda by a. You can find what a is. No. What I said is right. On a 30 degree on either sides means you write sine 30, but don't put 2 lambda. Don't write sine 60. Just write lambda by a. Oh, beautiful. How beautiful. I hope you all understood what I'm saying. I hope it's first getting recorded. Yeah. Oh my God. Yeah, what I assumed is right. This is 30 and 30 on either sides means it is not 2 lambda by a, it just becomes lambda by a. Don't put 60 degree and mess up the sum. Sorry guys, okay? World's most important mistake that I made is what is your learning. So sine 30 is equal to, never do that. So a is equal to lambda by sine 30. So you know lambda is 5000 into 10 to the power minus 10 by sine 30 is, what is sine 30? It's 1 by 2, right? So you should be getting 10,000. Oh, you got the answer. Into 10 to the power minus 10, which is 10 to the power minus 6. So 1 micrometer, that's done. So let's go to next thing. Next thing is when it is going to be 90 degree. So you know sine 90 is equal to lambda by a. So a is equal to lambda by sine 90. Again, is it that half the angle 90 degree? Yeah, half the angle. So sine 90 itself is 1. A is equal to lambda. That is when the wavelength becomes equal to slit width. So that's the condition at which it's happening. I hope you are clear. Lambda itself is 5000 10 to the power minus 10. So 5000 Armstrong is the answer for the second case. I hope you understood. Let's go to next sum. Beautiful sum. 20th question. A wavelength is 5400 Armstrong. Passes through a slit of width 0.12 into 10 to the power minus 2 meter wide and forms a diffraction pattern on the screen. Capital D is equal to 2.7 meter away. What is the width of the slit? The apparatus is dipped in water. Okay. How does the bandwidth of the central maxima change? What is the width of the slit if the apparatus is dipped in water? The wavelength will obviously change. Let it pass through a slit of 0.12. Forms a diffraction pattern 2.7 meter away. What will be the width of slit if the apparatus is dipped in water, and how does the bandwidth of the central maxima change? Bandwidth of wavelength is going to be wavelength is going to decrease when it is going into a denser medium. Then so then when wavelength decreases, the bandwidth also decreases. That much we know. Again, this sum, I feel the sum is question is incomplete because they have not given anything. They, the central maxima is the bandwidth, which is 2 times lambda into capital D by small d. You can find that. Yeah. And then you're going to the width of the slit if the apparatus is dipped in water, which means the fringe width is also going to change. Then how the hell I'll do this sum? I don't know. I don't know how to do the 20th question. I feel something is not all right with the question. It's very incomplete because something has to be given, right? So I don't know. I know that wavelength is definitely going to change. And how is going to affect my small d? I can find the new wavelength, yes. But the fringe width is also not going to remain the same. The small d is also not going to remain the same. Then it's not possible for me to continue with this sum. So you just check, give me the answer key and we'll figure that out. Let's go to 21st question. A laser beam of wavelength 7000 Armstrong has an aperture 1 centimeter small d. The beam is focused on the surface, the focal plane of the lens of focal length 5 centimeter. The beam is focused on the surface plane of focal length of the lens is 5 centimeter. Okay. Compute the aerial spread of the beam. Calculate the intensity. Oh shit. Okay. The fact that it says it has got aperture 1 centimeter, I think it's only diffraction. And the beam is focused on the surface placed at a focal plane of 5 centimeter. Focal length is 5 centimeter. The beam is focused on a surface at a focal plane of focal length 5 centimeter. So can we say that the d itself is 5? Since it's not been given, can I take the focal length to be approximately equal to d? Because normally the slit will be here, there will be a convex lens when it will come and it will converge and fallen here. There will be an additional distance here, but I'm trying to ignore that, and I'm going to call F as D. I didn't know what to do otherwise. Okay, so check with your teachers whatever they are saying. Compute the aerial spread, and the aerial spread is nothing but theta is equal to the entire spread, which is 2 into lambda by small d, which is 2 into 7000 Armstrong 10 to the power minus 10 by small d itself is 1 into 10 to the power minus 2. This goes up, this will become 10 to the power minus 8. This 3 goes up, it will become 10 to the power minus 5. So it's 14 into 10 to the power minus 5 is what I'm getting for the 21st sum. And they've conveniently not even given the answer. And how can it be 14 10 to the power minus 5, which is 0.00014, whatever is the radians is the answer that I'm getting, whatever it is. You can check with your teachers on that. Compute the aerial spread of the beam. So this will be your theta. The whole thing is for whatever angle you get, you have to half it because you need the radius. So you have to half this angle. I'm just assuming on this distance itself is 5. And since you know theta, sine theta, tan theta is equal to r by 5. This is what I am thinking. So if you know theta from here, you can cross multiply and get the value of r and write pi r square. Again, ask your teachers for the answer key for this because I'm not very sure of this sum. So let's go to, these are very, very difficult sums. And no board exams will ask you these kind of questions which are towards the end. The two spectral lines of wavelength, 5890 Armstrong. Another wavelength is 5896 Armstrong, which are falling on the slit normally. With the slit width is 2 micrometer. The screen is placed at a distance of 2 meters from the screen. Find the spacing between the first maxima as measured on the screen, respectively. Okay, these two will have its own first maxima, and its first maxima is 1 into lambda into capital D by small d. So for the first one, it's spacing between them. So for the first one, it's 5890 into lambda into capital D by small d. So it's lambda is over, then into 10 to the power minus 10, of course. For the second one, it's 5896 into 10 to the power minus 10 into capital D by small d. And the spacing between them is the question, right? You just have to subtract them. That's all. So capital D by small d will be constant, and 5890 and 5896 when you subtract, you get 6 into 10 to the power minus 10. If you know capital D by small d, it's 2 by 2 into 10 to the power minus 6 into 6 into 10 to the power minus 10. So then this goes up and will become 10 to the power 4 minus 4, and 2 and 2 will get cancelled. 6 into 10 to the power minus 4. Again, see, they have not even specified the answers for these sums. So I'm doing the 22nd sum. There's no answer given here. That's the spacing between the first maxima as measured on the screen. Let's go to next question, 23rd. The single slit experiment. They say single slit means it's diffraction. I hope I'm recording. Yeah. The lambda is equal to 450 nanometer. And the incident ray slit width is given to be 3 micrometer. Calculate the distance of the third bright fringe from the central maxima, which is 3 into lambda into capital D by small d, at which the ray optics is valid. What? In a single slit experiment, 450 nanometer, incident ray, the slit width of 3 mm, calculate the distance of the third bright fringe, but capital D is not even given, from the central maxima at which the ray optics is valid. Guys, can you please help me out with the answer key for the 23rd? I can't do this sum. So let's, that's all. I'm done with this. The rest of the sums, I'll try to make a separate video later, guys. Okay, whenever time permits.